Okay, we're looking at the remainder theorem. Now what I'm going to do is just explain the remainder theorem. Let's imagine that we don't know this polynomial. We've got p of x is the polynomial we are considering. So we're looking at p of x. Now what we've got is if we divide by this something, so let's say we're going to divide by x minus a, then we're going to get x minus a times by some quotient. Must equal p of x, and if it's a remainder we'll have some kind of remainder. If it's not a remainder, then this x minus a will be exactly a factor, and there'll be some polynomial q that will equal, when you times by x minus a, will equal p of x. So essentially what we're saying is if you want to write this as a fraction, so if you're doing p of x over x minus a, then that will give you some kind of quotient, some polynomial, plus some remainder that still needs to be divided by x minus a if you were to do the long division. But this is the remainder you get left over from the long division. So therefore, if we make the a equal to 0, make x minus a equal 0, so this bit equals 0, then the whole of this becomes 0 because that times that is 0. So therefore, if you put a into here, p of a will equal the remainder. So let's just do that. So we've got x minus 1. So if you've got x minus 1, we're going to let x equal 1. So therefore p of 1 will equal, put it into this formula for p, 1 cubed plus 2 times 1 squared minus 7 times 1 plus 5. And that will equal, what's that, 1 plus 2 is 3, minus 7 is minus 4 plus 5 gives you 1. So the remainder equals 1. Now let's do the same with the second question. So we've got x plus, so for part B, we've got x plus 2. So therefore let x equal minus 2. We want to make all of this 0. So therefore p of minus 2 will equal minus 2 to the power of 4, minus 2 times 2 squared plus 3 times 2 minus 1. So that's going to be 16 minus 8 plus 6 minus 1. So that's 8 plus 6 minus 1 plus 5 gives you 13. So the remainder equals 13.